Welcome back, and we continue our study on valuing annuities. Previously, in the first two sections, we studied the increasing annuities. That means the payment goes up, right, from 1 to all the way to n at time n. Now, in the next two sections, we study the opposite side. The size of the payments is actually going down. Okay, you start with n dollars, let's say at time 1, and then you go down to n minus 1 at time 2, then and so on until at time n you get $1. So it's exactly the reverse order of the payments we saw before in the increasing case. So what I mean is, when you draw the timeline, okay, the first type we study is annuity immediate. So the first payment will be at time 1. Okay, you begin with the highest value you will receive, which is n dollars. At time 2, you get n minus 1. So you see the size of the payment just goes down from n to n minus 1. Okay, you continue until at time n. At that time, you're going to receive $1. So we reverse the order, right? Remember, for the increasing, you have $1 here, $2, at 2 goes on to n dollars. Now you flip the order of all the payments. The first goes to the last, the second goes to the second to the last, etc. Right? So that's the decreasing annuity. So that's why there are so many formulas in this chapter and in general for this course. But as long as you know one, let's say you fully understand increasing annuity immediate, then everything else just it's a corollary of the results we derived there, because we know increasing annuity due, it's simply every payments move 1 year ahead, so you times by 1 plus I, right? If you have the corresponding perpetuity, you just take n to infinity. Then it's a simple calculus question, right? So now here we deal with decreasing, okay? Soon we will see the connection between decreasing and increasing annuities. As always, I want you to write down all the terms. So let's say we want to study the present value. So it would be this notation. It is at time 0. Notation-wise, it's easy to understand, right? Everything makes sense. Now we deal with decreasing. So we change IA to DA. I stands for increasing, D obviously means decreasing, right? We deal with annuity immediate, so it's a plan A without double dots, without bar, okay? This is the term annuity. We have n payments, so it's A angle at interest rate I. The first payment is n dollars discount by 1 year. Okay, second one discount by 2 years goes on. The last one discount by n years. Okay, that is usually what I try to convince you to do. Draw a timeline, write down or label all the payments on this timeline you just wrote, and then the next step, try to analyze whether you want present value or you want the future value or the accumulated value. For the corresponding choice, you either discount or accumulate, right, by appropriate years. The first one is the time 1, so I discount by 1 year, so it's number times V. Second is number times V squared, because now I'm at time 2. Right? Finally, I have $1 and I'm at time n, so it's 1 times V to the n's. Right? So this is the general summation. I want to get a better result. Right? I put by using our usual trick, which means you're going to times by 1 plus I on both sides. Right? So I do it one more time. 1 plus I times both sides. I will get n plus n minus 1 times v. So basically all the power of v will be reduced by 1. Okay, now let's do subtraction. On the left hand side we have this. Okay, and again we do the subtraction for the same order. So I get negative v, right, because it is short by 1. Then it's negative v squared goes on to actually everything is negative. So let me write negative minus v to the n minus 1 and finally minus vn. Okay, so let's factor out all the negative sign and put a bracket. Okay, so if you do follow my strategy, this, well, you should know, right, that is just the present value of annuity immediate, right? So at this step, you should be able to see the result inside this box. If you want to call this formula, well, you may, because it is a formula. But the to derive this, well, takes 10 seconds. And if all you are trying to do is to hard memorize those formulas, it is really an unhealthy way of learning. This is not learning actuarial science. Learning actuarial science is not equal to memorizing formulas. Okay, and even if you do, you might be able to memorize for a very short period. Okay, may not even last to the exams. Okay, not to mention after 2 years or when you graduate, you probably won't be able to memorize any of them. That's why throughout this course, I try to emphasize that the essence, the fundamental is time value of money and the basic mathematics. That's why every time I break down all the terms like in this way, okay, that is the fundamentals. This is something once you study, once you understand, you will be able to memorize them forever. Like I never took any actuarial science course. I studied everything by myself, and that was 8 or 9 years ago. That's the first time I studied FM, and I passed the exam in 3 weeks. And even by now, that doesn't need any time for me to prepare this lecture. Once you understand forever. That's why I really, really want, or at least I really, really hope you to try my method. Okay, to see, to at the beginning you may have some trouble. You may face a lot of challenge. Once you get through that step, your future path to becoming an actuarial will be much, much smoother, and you will likely have a better career. Okay, so if you build a nice foundation of mathematics at the beginning, because later on, when you are junior, when you are senior, there will be more advanced courses that you can't survive by memorizing formulas. Okay, so I would really hope you try. Okay, this is how you derive. This is one way to understand. Okay? I always provide multiple ways for you to understand. Hopefully one of them will work for you. Okay, if not all of them. So here I provide a different understanding. So on top I draw decreasing. Right, goes on. Let's draw a little bit more. So here is 2. Finally, I get $1. Okay, let me switch to a different color. I do 1, 2, 3. So you see what I'm doing? I'm doing increasing. Okay, so on top is the decreasing annuity immediate we just introduced. At the bottom in blue color is the sequence or is the cash flows of increasing annuity immediate we introduced in section 1. Now, let me get another color. Let me include them together. Right? So both payments are at the same time. So I can directly add them together. I get n plus $1 at time 1. I get n plus $1 at time 2. I get n plus $1 at time 3. and so on. What does that mean? So this is a way of constructing a new annuity, right? Increasing annuity immediate plus a decreasing annuity immediate becomes a level annuity, right? So that's why I have this formula, right? On the left-hand side, I have one decreasing, let's say that's the pink payments. I have one increasing, those are the blue payments. Finally, I have those brown payments. They are level annuities with payment n plus 1, and everything else is the same, right? I have n payments. Okay, the size is n plus 1. It's a level annuity, so I don't have I don't have D. It's just a standard annuity. This is how I prove this result. Right? All I did is draw a timeline, put the payments of 2 annuities along this timeline, and by quickly identifying, if I summarize those two at any time point, the payment is n plus 1. It's a level annuity. So I have this result. So you can apply, for instance, we proved that this is the formula for the increasing annuity, and now we want to know the decreasing one. And obviously, we easily know the result for a standard annuity immediate, right? So from here, we can also get the same formula we just proved in the previous slide inside this box. So try to finish this, right? Let me see. I think here we have a standard annuity immediate, but here we have annuity due, right? You can convert it to annuity. So this is just a 1 plus I times annuity immediate, right? Okay. This will be, well, if you plug in this formula, you get ANI plus 1 minus BN, right? So, well, the rest should be easy, right? You can plug in to check whether you get the same result. In case you can't, please let me know. Of course, I can help you with that. I leave the details to you. Leave a little bit work with you so that get you a little motivation to work on yourself. Let's do 2 examples. 3.5. Let me get my book, and we will do this together. 3.5 is on page 65. So here, Amelia receives $400 in 1 year, $350 in 2 years. Okay, so you can see it's decreasing. 400 at time 1, 350 at time 2, 300 times 3 goes on until the final payment of 50. First of all, we need to figure out what would be the time. So this is a decreasing sequence. So what we have is, let's say xt equals the original one minus the difference. Now it's a negative number because it's decreasing, t minus 1. Okay? So x1 is 400. The last one is 50. 400 minus 50 times t minus 1. Okay? Move it around, we get, okay, we can divide it by 50. Move the negative to the other hand side. So it's 8 minus 1. So it's t is 8. Right? If you don't understand this, again, get your fingers. Right? So 400, 350, 300, 250, 200, 150, 100, and then 50. Right? So what numbers? Right? So you will be able to get is 8. What do we want? We want to know the present value. Okay. So now let's write down the present value. This is nothing but definition. Right? Many of you somehow, don't understand or don't like the way I write it down in the first step, or you can call it second step, because I usually say first step is to draw the timeline, label the payments. The second step is to write down all the terms to be summed. That is because at this step, you can use a calculator to get the answer. Right? What is I? I is 3.5%, meaning V is 1.035 to -1. Even you don't know any formula, even you don't understand any formula, from this step, you can use calculator and you can get the right answer in less than 1 minute. Right? You can, with the scientific calculator, you can continue to do this. Right? 400 times this plus 350 times V to -2 plus 300 V to -3 here. I mean, you can go on, you can get the answer in 1 minute. No formula is needed as long as you understand this. Right? Of course, sometimes it could be the number of terms can be crazy, like 30, 40. If you still want to do it by hands, well, it will take you longer time, and you are more likely to make mistakes. In that case, you do need formula. Right? But formulas are built into your calculator. You are the one who should understand. Right? If you understand what it is, then again, it's straightforward. Uh, this is not a standard decreasing, right? Because this is because it's a multiplier of 50, right? So if you divide everything by 50, let me use blue. So if I divide everything by 50, this is 8, this is 7, this is 6, okay, then it's 5. This is 1. From here, you also know the time is 8, right? So this is the A8 at I. Okay, get your calculator to finish the final result. We have one more example to go, 3.6. Determine the present value at time 0 of payments of 5,000 at time 1, 5,000 at time 1, 4,950 at time 2. So you go down by $50. Right? So I don't want to continue, right? Down to the last payment attempt. So let's calculate the payment attempt. So it will be the initial one, 5,000 plus. You always go down by $50. So the difference is -50. You go to 10. 10 minus 1 is 9. So 4550. Okay. This is because I'm using the general term of arithmetic term, which we studied before chapter 2. Okay. In this case, this is not a standard decreasing annuity because you cannot just divide by this number to get 1 and hoping everything else will be 2, 3, or 4, right? Then we need to decompose, right? We have done this in the previous sections. So this must be 50. Then I have 4500. Okay, goes on. 4500. Then we have 450. So now I can write it 4,500. The remaining will be 500. 500 is 50 times 10. Again, I can see here 10 is good because that is where I get my last payment, right? So by the reversing order is exactly what I expect. So now I have a level payment, 4,500. It's a standard annuity immediate for 10 years at interest rate I, which is 5%. I have another decreasing annuity immediate with, well, the factor 50. That's why I times by 50 is decreasing annuity. So I use DA. Okay. There are different ways to understand, right? So this is, well, it's never unique, right? So for instance, I can write, well, let's do something different. Let's do minus 5050, right? So 5,050 minus 50 is exactly 5,000, which we receive at time 1. Okay, then I will get negative 1,000. So let's handle the level part first. This is easy, right? The size of the payment is $5,050. It's a standard annuity immediate for 10 years. So this is the present value. Now let's handle the uh, strange part, which is negative. If you factor out this negative, it becomes 50, 100, 150 goes all the way to 1,000. So it's minus 50 IA, right? So in method 1, we use decreasing sequence. Here we have increasing sequence. It really depends on how you see this problem. There are infinite ways of decompositions. You just need to understand one, right? Then you should easily generalize to any decomposition of your preference, right? So I gave you two. Well, it doesn't need to be like this, right? You can do something different if you want. Accumulated value. In case you really want to memorize, at least don't memorize the accumulated value formula, because as long as you know the present value, you simply times by the accumulation value factor, which is 1 plus I to the number of years, right? So never memorize them at the same time, because as long as you know one, you know the other easily, right? So this has no trouble of understanding at all. It works for anything, any annuities, right? One is at time 0, or one is at the beginning, the other one is at the end. In this case, it's 0 at n. So the number of years is n. So you raise the power to n. That's it. I leave this space because I actually want you to analyze. Right? I mean, I can do this forever for you. Right? It's time for you to actually do this kind of analysis. For example, the first payment is n. It is at time 1. I want it to be at time n because I'm calculating the accumulated value. So how many years? N minus 1. Right? In total, we have n years. Okay, 1 year has gone by, meaning you are left with n minus 1 number of years. Okay, then the next one you reduce by 1, goes on until the last one. Well, it's just 1, right? It's time 0. So, or you can remove that. So that is the analysis I want you to do, and then you can times by the usual trick, right? You times by a factor, and then you do the subtraction between them, you get the result. You can get this result. Okay, work on that. I leave that to you. Then we study decreasing annuity due. Right? Once you know annuity immediate, annuity due is trivial. All you need to do is to multiply by 1 plus I. That is all you need to do. Right? Of course, I begin with standard definition, meaning I would help you to draw this. Okay, and then it's n minus 2, n minus 1. Here's n, here's 1, here's 2. Okay. When we calculate the a double angle or a double dot, it is at time 0. So ds double dot, it is at time n. Okay. Although the last payment 1 is at n minus 1, that refers to the beginning of year n, one period ahead, but you move everything to the end of this annuity, not n minus 1. Okay. So the future value or the accumulated value is not there, but at n. Okay, that is something slightly different from the case of annuity immediate. Okay, so what I mean is, so let's be precise. let's be precise and actually write the AN, put the angle N. So let me move it aside so I can select the pen. Okay, so this is, all you need to do is do this, right? And then we get everything, right? Remember previously we divided by I, okay? Now you times by 1 plus I, you can move 1 plus I to the denominator, right? Then it becomes I over 1 divided by 1 I divided by 1 plus I, that is D. So the denominator becomes D. That's why, you know, the textbook has a trick, right? When you have annuity due, you divide it by D. When you have annuity immediate, you divide it by I. When you have continuously payable annuity, you divide it by delta, which is the force of interest. Okay. Do this. By now it's obvious, right? So the first one, no need to discount, so it's N. The second one, discount by 1 year, goes on. The last one, discount by N minus 1 years. Apply the usual trick to get this formula again. So there are two different methods. One is to apply the direct connection between annuity due and annuity immediate, because on the right-hand side, we already know the decreasing annuity immediate, right? So apply this, you will get the result, and then you can apply the usual trick times by the factor, do the subtraction, and prove this again. This we already did, right? So it's the same for annuity due. So put $sign to show this is payments. Okay, so now I want increasing. Increasing, here is 1, here is 2, here is 3, goes all the way to here is m minus 1, here is n. Right? So of course, when you add them together, it is always m plus 1. Right? The same idea, except now you have annuity due instead of annuity immediate in the previous case. So that's why here we have another way to prove the result, right? The result of this. Right? So once you know the present value, apply a factor, you get the accumulated value. So there's no need to memorize both PV and AV. Knowing one is definitely enough to get the other. I put an example here, but those are very, very easy examples. So I think I can leave that part to you. I can trust you to do that kind of exercises. I believe they even don't put it in example. They just give you some numbers and ask you to calculate. For instance, on page 70, you have let's calculate the accumulated value at time 10 years of a series payments of 100. Now 90 in 1 year, you know, so it's a standard decreasing annuity. Now you have a factor. My factor is 10, so it's simply 10 times D S double dot, and you have 10 payments. The interest rate is 3%, and then you can plug in the formula to get the result. Okay. I think let me stop here because moving further is continuously payable. That is always the challenging part because you don't really visualize the payments at say time 1, time 2, etc. Right? It's continuously payable, so you wouldn't be able to really draw the timeline to label the payments. That's why it gets a little confusing. I will leave it to the next video to study. So let me conclude here and see you in the next video.